Hey guys, Dr. B here. So we're going to cover position and time and how that relates, it's going to eventually relate to velocity, acceleration later on in the unit. Up here is a general example we're going to follow. Below is a sentence that is one that y'all can relate to. Over here is a T-chart with time and position. Time is in seconds, position is in meters. Here, the bottom is, you can say it's a quote meter stick, but it's not really. It's just a visual to help us understand what we're doing and where we're going and our values, etc. So let's say that you're driving Bumblebee from home and you're going to pick up your friend from his place to take you to school eventually. So from home to your friend's house, your time was 0 to 1 second. For example, your position at 0 was 0 meters. Your position at 1 second was 4 meters. After you picked him up, you decided to go to school, hopefully. You drive from your friend's house to school. So that means that at second 2, you reach school, and that will be, your position is 9. Not necessarily 5, but your position related to where you started off from is 9. So that's our first example for position and time graphs. So in case 2, you are starting off at home, driving to a certain point, and backtracking. When I say home, I mean 0 meters. So in this case, you are driving from home, you're picking up a friend, and driving to the mall. So looking at our meter stick, you can see that the mall is in the middle. So we're going to start off from home and drive to our friend over here. So we're from here and we're going all the way over here. So at time 0, you are at 0 meters. In 1 second, for our example, you're at 9 meters. Then from your friend's house, you're going to go to the mall, but in this case, you're kind of going back towards where you started from. At time 2, your distance is 4 meters. Remember, you're not like subtracting from 9 or 4 or anything like that, but you're just indicating what position you are at a specific time for this. Okay, so let's look at scenario 3. From home, I drive to the mall and then drive back home afterwards. So if you look at a general diagram, you're starting off at 0, going a certain distance and heading right back. So let's say you take your car. How will we visualize this? So we're taking our car, we're driving into the mall. So at time 0, your position is still 0. So 0, 0. At time 1, you are at 4 meters. So then, like we said, we're going to head back home. So at time 2, from here to here, at time 2, we are back at 0 meters. So we went from here to here, and then afterwards we went from the mall back home right away. So in scenario 4, from home, I am driving to the mall and then visiting my parents afterwards. So our general diagram, you're going some distance to the positive direction or to the right, and then you're going past your house, past 0, and going in another direction towards the left, or the negative side, if you will, for this. So again, just to visualize, from home to the mall, so from here to here, time 0, your distance is still 0. Once you reach the mall at 1 second, this will be 4 meters. But then at 2 seconds, I'm going from the mall and going to my parents all the way over here. They are at -6 meters over here. So in terms of positive versus negative, I'm not saying they live in a negative area. I am saying that compared to when I went over this way in one dimension, I'm going the opposite way in the same dimension as well. So it's only from left to right or right to left. There's no other variable coming into play here. You're just going from left to right or right to left based on the scenario you're given. Thank you for watching this video. Hit the subscribe button if you want. We will come back to this scenario with these values later on in this unit when we start talking about velocity, acceleration, displacement, those types of vector quantities.